Okay, so lesson 14, quality of service management. In lesson 9, we had a discussion of a service at the database level. And we were able to use resource manager to allocate the different amount of resources if multiple services are running out of the same database instance. So we were able to control quality within the database level. Is it possible to monitor service at the cluster level? So it doesn't matter whether service runs out of a service exists for the same database or multiple services are available across our database instances in the cluster level. So we want to monitor service in the cluster level. So by doing so, we want to actually monitor and also detect some performance issues, and also when needed, we want to make some recommendation. So that's what we want to achieve here. Quality of a service, it is to manage service in the cluster level. Okay, so you may have a service in one database, and another service in another database, another service to another database. So we want to monitor performance of services in the cluster level, and also you set some objectives. And if a service performance is worse than your expectation, so then we should be able to receive some recommendations. Now, quality of a service will give you that kind of information. And in this lesson, we will learn quality of service management and benefit of using Oracle database quality of service management and components and operations. Quality of service management background. And traditionally, we manage it, each application in the dedicated environment, and based on the peak time application resource usage. So if you have the 5 or 6 applications that must be deployed, then we had to prepare 5 or 6 dedicated servers or dedicated clusters to support each application to run it optimally during the peak time, so adding enough resources. But by doing so, we may have a lot of unused resources, because in your environment, not all applications may consume all of resources allocated. So at some point, one application may require more resource while other applications are idle. So we should be able to reallocate resources for another applications that require more resource. But with a dedicated database and application environment, it's very, very difficult to manage resources for all of the applications. That's why we have a grid infrastructure concept or cluster concept or cloud concept to manage resources more efficiently. For example, this is in one dedicated environment, a 3 dedicated cluster environment. Suppose that you are deploying 3 applications in the 3 different dedicated environment, and you allocated enough resource, okay, to run app 01, app 02, app 03 optimally. So here we have the 3 separate clusters and 3 separate database on the cluster, and we also created a service as the mean of the application the connection. Okay, so in this case, suppose that at some point this application is actively running in this environment, while these 2 applications are idle or consume very minimal resources with a minimal workload. The question is it possible to allocate one server from this cluster, another server from this cluster? So that way, App02 can have up to 5-node cluster. So my application on this server may have more resources available. So again, more benefit from more resource. Technically, yes, it's possible. Okay, but there are so many manual tasks that must be done. For example, you have to remove a server from this cluster. So how many steps are required? And also, you have to add it as a new member of this cluster. How many steps are required? Same thing. You remove a server from this cluster and to add it to this cluster. How many steps are required? And in the different time period, if other applications require more resource, then we have to relocate this server back to original cluster. So how many steps are required? And this is too much work. That's why, for better, resource management, rather than creating small many clusters, we can also create single large cluster. Okay. In this example, 9-node cluster. Okay. And also, for better management of a database and resource management, you can subdivide your cluster, but not physically, but logically. Okay. So that is a server pool. So first 3 servers grouped together at the server pool level. So we have App01 server pool, and also second 3 servers grouped together. So server pool name is App02 server pool, and third server pool also grouped 3 servers. And we've deployed the database, and your databases are running here, and your applications are connected. Okay. In this example, assignment of a resource from one server pool to another server pool is very easy. It's only single command is required, because physically all these 9 servers are members of the same cluster. Okay. So we can just change the ownership of a server from one server pool to another server pool at the logical level. That's it. And in this environment, we have this service where application is using, and also it's another service and another service. So in this single large cluster, there are 3 services across 3 databases. Okay. Now, is it possible to monitor the performance of each service in each database? Yes, it's possible. That's what we learned in lesson 9. By default, Oracle collects 2 metrics, service time metrics and CPU time metrics at the service level in a specific database. But is it possible to monitor performance of all 3 services in the cluster level, not the database level? Okay? And this is possible. That is by going through quality of a service. What quality of a service does, quality of a service, it collects metrics collected from each database at each server, and then receive that information, and then check with the quality of a service plan. So you as an administrator, you will have to create plan to manage resources or to manage the performance of these services. How do you want to monitor these services in the cluster level, and what is your target if one service runs slower than expected? And how do you want to make? How do you want to fix? How do you want to handle? Okay, so that is done actually through quality of service and also quality of service plan. Okay, this matrix is already given information. So service level metrics from the database, OS level metrics from each server where clusterware is installed. There is a cluster health monitor utility in the cluster server, and we can also collect OS level statistics in addition to database statistics in the cluster level. So quality of a service leverages existing information from the cluster server component and database component to understand performance of a service in a better way. And then quality of a service can make a recommendation when needed. For your information, quality of a service is focused on OLTP type of a workload, okay? Not for the data warehousing. So it focuses on service time, okay? Monitoring and service time based recommendation. Okay, so here we have the overview. So to use this feature, you will have to define and enable quality of a service, and your workload must be classified, and also your the service level performance must be measured, and then based on your plan, quality of a service analyzes current service performance, and then when needed, it can make recommendation. And we as administrator, if a recommendation is acceptable in your environment, you can implement it. So a recommendation may be, okay, so we need to allocate more resource to one of the server pools to add more resource eventually to improve the performance of a service running on that environment. So if that is acceptable, you can implement it, and you can finally review result. So that is actually the quality of service management. And we have a simple way to manage the quality of a service by going through a policy set. So starting with the 12C, we can use a policy set. It allows us to create one or more policies in advance, and then we're gonna use it. We're gonna use it to manage resources. Whenever we need, we activate one of the policies, and then quality of a service monitors the performance of service based on policy that is activated. Quality of service is a feature of a database product family. It was introduced in 11GR2, associated with a rack software initially. So initially, it was only for Exadata database machine. However, in the current version, quality of a service, it can be used non-Exa database environment as well. But it is focusing on OLTP workload management. Okay, so we can create one or more policies, and you activate policy to manage OLTP workload pattern by going through a service management by using quality of a service. Quality of a service, it focuses on monitoring application performance and analyzing application performance. This application performance is very similar to database time, what we learned in lesson 8. If you remember, in the beginning of lesson 8, we learned the database time. The database time is a database activity time. It is composed of database CPU time, so DB CPU time, and also DB wait time to complete certain operations. Same thing. Application performance is measured by quality of a service, consists of a resource usage and also resource weight. What quality of a service does, if a resource weight goes up, then quality of a service tries to make a recommendation to reduce this weight. So by doing so, we can improve overall application performance. That is the main focus of a quality of a service. And the benefit, it determines where additional resources are needed. Okay, so in order to determine, it does use metrics from OS and database level, and it compares with your service level agreement that is a part of your plan. And it determines whether additional hardware can be added to maintain acceptable performance. Quality of a service also uses server pool as a foundation of quality of service management. If you have if you have a server pool concept, it's easy to understand. When you create server pool, you create server pool policy. Okay, so the policy include importance. So what is the importance of this server pool? And also minimum number of servers that must be maintained. What is the maximum number of servers that can be added in a specific server pool? So if the application runs slower than expected, quality of service examine all these server pool policies, and then check if it's possible to add additional hardware to maintain better performance. And also, it reduces number of critical performance outage by detecting performance issue in a very early stage. And also, it reduces time to resolve performance objective violation. And it improves system stability as the workload changes. So we can easily change the policies. You can activate the policies quickly. And also, it ensures that service level agreement are met. So SLA, this is actually part of a plan. We use a performance objective. And performance objective is actually service level agreement. So you will have to set your the agreement level, and then quality of a service continuously compare collected statistics information with your given service level agreement information. And also, it facilitates effective sharing of hardware resources. Quality of service management, it works with the rack and clusterware. And clusterware provide server level OS metrics through cluster health monitor utility. So OS metric statistics is available. And also rack database provide service level and database level statistics. So quality of service gathers all this information and analyze it. And then quality of service try to manage database server CPU resource. And also it can check wait time as well. And it can make recommendation like this, adjusting size of a server pool, and also consumer group remapping. And it can also manage memory pressure. The way it manages the memory pressure is it can control number of sessions, okay? And also it can detect runaway workload. So if one workload and one query eating up large amount of resources, quality of a service can easily detect this problem and then control workload and also number of sessions to manage memory pressure. And we can create one or more policies, and we save it in the policy set, and we can activate one policy at a time. So your server pools will be managed based on policy. And also you will have to create performance classes to manage the service across the servers in the cluster level. And also you will have to define performance objective, business rank, and server pool allocation. So this is an example of a server pool. It's a foundation of a quality of a service. So in this example, there are 1, 2, 3 user-defined server pools. Online server pool, its minimum size is 3, maximum size is 4, importance is 30. Higher number is more important. And back office server pool, minimum size is 2, maximum size is 2, importance is 2. Batch server pool, minimum is 1, maximum is 1, importance is 10. If there is a new server available, and this server will be added to one of available server pools, the first thing what Oracle Clusterware checks is a minimum number. So this server pool, online server pool, it has enough number of servers comparing with the minimum size. And back office server pool, it has enough number of servers. And batch server pool, it has enough number of servers. And then we're going to check maximum size. Okay, it is already maxed out. It is already maxed out. It is already maxed out. So, we still have one unassigned server. But suppose that, our maximum size of online server pool is 5, for example. So we can add one more server, so newly added server can be assigned to online server pool, okay? And then we manage the performance of applications through services, okay? So service level statistics is collected, and also cluster level statistics is collected by going through cluster health monitor utility. And we will have to create performance class. Okay, it's a workload separation, and we use we create performance class. Okay, to associate it with service that exists in a specific database. Okay, and then we're gonna set performance objectives in each performance classes. And each year work in each session will be tagged. So if one session requests any work, and then Oracle will know whether this session belongs to which performance class, and then we can actually control the performance of a service by doing so. So each session is classified, and each work request is tagged. And we can create policy, many policies, but we can only activate one policy at a time. And also, if performance of a service is worse than your performance objective, then quality of a service makes a recommendation based on performance class ranks. So we have highest, high, medium, low, and lowest. So based on this rank, quality of a service will make a series of recommendations. And performance objective, this is your service level agreement. Okay, you will have to set performance objective as a service level agreement, so that way quality of a service collect OS level and database level statistics and compare with the service level agreement, and then makes a recommendation based on this performance class ranks. And we use a metrics that is one performance measurement. So this performance metrics will be used to compare with the performance objectives. Eventually, quality of a service can make a recommendation. And you can create one or more policies to manage the servers in a different way based on application needs. So in this example, we have a business hour policy, after hour policy, and end of a quarter policy in a different way to distribute resources. There are two types of metrics. One is the performance metrics, give an overview of where time is spent in the system. And resource metrics measure the time that work requests to use a resource or wait for a resource. And metrics are used to identify bottlenecked resource, and we compare with objective. And in this example, you see the architecture. Database makes JDBC connection to quality of a service, and Oracle ClusterWare component SRVM, it connects to quality of a service. And at the operating system level, Cluster Health Monitor, it works with the quality of a service. So after collecting amount of information, quality of a service will use policy engine to see current performance of a service is worse than the expectation. If that is the case, generate recommendation based on performance ranks. So that is the idea. So when you look at this diagram, and you will see this. You can create quality of a service plan. This is an example. So for example, I want to create daytime plan. And I have a performance class. So I have 3 separate pattern of a workload in the cluster. One is App01 class, another one is App02 class, and App03 class. Now these classes are associated with services. So in this case, we have a App01 service on DB1, App02 service on DB2, App03 service on DB3. And then we associate performance class with the service. And also, you're going to set service level agreement. That's a performance objective. This service must achieve as an average 0.5 second per call. Actually, this is a given information, right, from the database, from the database running on each cluster. And also, 0.7 second per call and 0.1 second per call, for example. And if my applications are running slower at the same time, then which application must be served first? In this example, App01's application and service must be served first. Why? Because its rank is the highest. Rank is nothing more than priority. And also, the metrics, application performance, is continuously collected and compared with the performance objectives, and then take action when needed. So that is the idea. So here are the recommendations. Performance objectives are not being met, then quality of service can make recommendation. So you can actually change the consumer group and the consumer group mapping, and allocate and deallocate resources among the server pools, and also moving CPUs between databases within a server pool. And these are possible recommendations. Using Enterprise Manager, you will see quality of service in API, the GUI interface, and then you will see projected result and also possible recommendations in order to implement, how long does it take. So you will see this kind of information. Starting with the 12.2, quality of service also support admin managed rack database. Earlier, quality of service was used only for policy managed database. But there is some limitation, when managing admin managed rack database using quality of service. But starting from 12.2, quality of service also can support admin managed rack database. So that is a new support in 12.2. And we have a quiz here. Oracle Database Quality of Service Management helped to meet the performance objectives by reducing resource usage. No, it's not to by reducing resource usage. It is by reducing wait time. Okay, so that way overall performance of the application will be improved. And also, Oracle Database Quality of Service Management recommendations can include moving servers between server pools. Makes sense? Adding spindles to improve I/O performance. No, quality of service will not make any recommendation on underlying storage directly. And also remapping the current user to a different consumer group. So yes. And also recommending partitioning strategy to easy global cache bottleneck. No, I don't think so. So the answer is A and C. And this is lesson 14 about quality of service management.